Welcome back to Industrial Problem Solving. My name is Dave Roysum. In previous modules, we gave you dozens of tools and techniques for figuring out what makes a problem work. In this clip, we cover option generation and decision making. Our day often begins and ends with meetings, and has meetings in between. Meetings are usually a necessary part of all the major segments of the problem-solving process, including decision-making. Thus, you had better be really good at meetings, no matter what you do for a living. Problem solvers, this means you! Even though the core of problem solving is usually best done in very small groups of 2 or 3. We will have more to say on optimum team size in the pitfalls of problem solving section. Please pause the tape and read, reread, and meditate on each of the best practices listed here. Your effectiveness, your career, and your company's profitability all depend, in part, on how well your company handles meetings. A good facilitator can really help make meetings more effective. Often, the boss fills that role, even though they may not be the best person for that job. A good facilitator encourages everyone to participate, but yet will not get involved in the subject matter themselves. Please pause the tape, read and reread and meditate on each of the best practices listed here. Your effectiveness, your career, and your company's profitability all depend, in part, on how well your facilitator handles meetings. Brainstorming is a very special type of meeting that requires very special skills to facilitate. The goal is to get as many ideas as possible out on the table. One way to kill the process is to have the boss define the problem too narrowly, such as fix customer complaints but don't involve the customer, or fix defects but don't change the machine. Equally bad is we can't do that, or we've tried that before. Brainstorming in such environments is a total waste of time and frustrating for everyone involved. If the brainstorming process goes well, you are likely to have way too many options. But that's okay for now. But soon we need to thin and trim. Yet we have to be careful here because we can waste time if we discussed every item in detail. On the other hand, we might toss out a reasonable option if we thin poorly. So we start by thinning the worst options first. These would begin with, for example, those that violate the laws of physics, or are clearly not affordable, or where the outcomes are just so uncertain because either the problem or the option is just not clearly understood. Next, we thin further by defining additional constraints. We may not wish to rebuild our machine. Or maybe we don't want to change our material or approach our customer and so on. Just be super duper careful here. If you define too many constraints, you will no longer have any effective solutions remaining. This is the fix it but don't change anything pitfall that we will discuss in more detail in a future module. Anonymous suggestions and anonymous voting solves many problems, both now and in the future. Take the top 3 ideas and discuss them in detail, perhaps rewriting them if needed. Then vote again. Consensus is nice if you can get it, and in some cultures it's even required. Please pause the tape, read, reread, and meditate on the consensus concepts listed here. Before you commit to a final decision, you or someone needs to do some serious soul searching. Almost every decision, even those involving mostly physics or engineering, has far-reaching and possibly subtle effects. Here is a checklist ranked from the serious to the subtle. Please pause the tape, read, reread, and meditate on how your engineering choices affect others. Once you commit to a decision, it is very, very hard to change the course later on. Thus, you and your company deserve a last sanity check to make sure that you've not overlooked something. Please pause the tape, read, reread, and meditate on sanity. In the previous slides, we discussed important aspects surrounding the decision-making process. Here, we discuss the decision itself. In an ideal world, you would be making your decisions based on economics, specifically maximizing profit or, if not possible, minimizing loss. Your company probably requires a formal analysis for capital approval, such as when buying new machinery. Options are ranked and must satisfy a minimum ROI. For example, rebuilds, upgrades, or new machines might need a payback of 1/2 to 2 or even 3 years. Part of the reason for this conservative requirement is that projects tend to cost more and deliver less than the optimistic funding requests made by the engineers. In short, your proposal is riskier than putting money in a bank. Please pause the tape and reflect on how well do you know costs, benefits, and risks. Economics can also help us with more mundane, everyday choices, such as best roller diameter, the best tension, the best dryer temperature, and so on. Here, the concept is that, for example, there are sets of high tension defects, and there are sets of low tension defects. In that way, tension, or any other parameter, is neither good nor bad. It is both good and bad at the same time. Your job is to find the economic minima of the cost curve. It is, as the saying goes, finding the best place between a rock and a hard spot. I have written on this on many occasions. Nearly all of my 5,000 Web 101 students are taught on how to apply economics for centerline choices. The idealized world of using ROI to decide among options or economics to find the best setting is, well, ideal. Yet, seldom do we know the inputs well enough, or seldom do we have time to study things in that kind of detail. Thus, we need to guess. Guessing can be made more formal using the method of weighted factors. My wife and I actually used this method to pick my first job after college, and we ended up at the Beloit Corporation. Here, I illustrate the technique for picking a builder for your new machine. They will be rated on criteria such as cost, performance, delivery, and so on. What many people do not know, however, is that there is a fair bit of uncertainty using this method. It is guessing about criteria and then multiplying by guesses of ranking and then adding the resulting guess times guess together to get overall merit. As a consequence, the formal technique requires the resulting best to be 20% better than the next best, else there is simply not enough distinction with this method. Thank you so very much for joining me in this problem-solving process. I hope I've made the case that decision-making is a very important part of this process, and that there are plenty of best practices to consider. However, we are still not done yet. Simply deciding does not get the job done. Stay tuned for the next module where we will outline project planning. Thank you.